Hey everyone, Chang here and welcome to my channel. Today I'm going to add on to an already difficult and confusing topic. That's right, today we're going to elaborate more on fractions. So in a previous video I talked about what fractions are and the different representation of fractions. But for today I'm going to talk about the superpower fractions. So basically the idea that fractions can actually be broken down into smaller parts, exactly the same amount but smaller representation allows us to work with many different fractions. So by the end of this video, you're going to know how to change the denominator of fractions. So with that, you can actually do things like adding fractions, subtracting fractions, and even comparing two different fractions to see which one's bigger or smaller. Let's start off by recapping what fractions are. So here's an example of a fraction. Notice this. There's three different distinctions. You have the top number, which is the numerator. You have the fraction bar, and the bottom is the denominator. The denominator of the fraction tells us that for a single unit, how many equal segments are we going to break that single unit? Well, in this case, this is 1/2. So for this single unit, we're going to break it into two parts. Now, the numerator actually tells us how many of those parts we're actually interested in. In this case, is only one. So one out of those two broken down equal parts. Now that was wonderful, but as we start working with fractions, we realize that there can be some difficulty. For example, if we have 2/5 plus 1/5, now that's okay because 2/5 is just saying that we break a unit into 5 equal segments and we're getting 2 of them. Now if we add 1/5, instead of the 2 segments we worried about, we want one more of those segments, so it ends up just being 3/5. That's not bad at all. But now, when we start adding different fractions, so for example, 1/2 and 1/3, it becomes a jumbled mess because 1/2 is a different length than 1/3. Adding them together, we really can't figure out exactly what that means. Well, especially when we start comparing fractions. Well, here we have, for example, 5/11. And another one, we have 22/44. Well, guess what? Which one is bigger? Which one is smaller? They look completely different. Well, luckily for us, when adding fractions, subtracting fractions, or comparing fractions, something like this, for example, here we have 2/6 plus 3/6. That's easy. The answer is 5/6. Or when we're comparing two fractions, we have 20/44 and 22/44. That's easy. 22/44 is clearly bigger than 20/44. Now notice these two examples. The key to helping us solve them very easily is the idea that they have the same denominator. Because they have the same denominator, we know that when we break down the unit into their equal segment, we're talking about exactly the same length, exactly the same segment. So the numerator just tells us exactly what we need. When we're adding them together, we're going to add the numerator together. When we're comparing them, we're just comparing the numerator of the two fractions. Even better is that when we change the value of the denominator, we can actually change it in a way that still keeps the same value for the fraction. Now, what do I mean by that? Well, first and foremost, remember that when the denominator is different, the difficulty is that the different segments we're working with are of different length. Well, if we change the denominator into the same denominator, then we're comparing the segments of equal length. Now, even better is that when we don't change the value, when the overall value of the fraction is the same, that means the original amount of the length that we worried about is the same. So we can actually work with it without worrying about it changing the whole problem completely. So here's the trick. Let's look at this. Here we have 1/2. Once again, remember 1/2, we're taking a unit, we're breaking it into 2 equal segments, and we only want one of them. Well, we have another thing. Here we have 2/4. Notice this. We're going to get the same unit because the unit is always the same. We're going to break it now into 4 equal segments, and we're going to get 2. Well, guess what? The 1/2, that length of the 1/2 and the length of 2/4 is actually the same. And actually, it works with 3/6 or 4/8. All their length is still the same. Now notice this. We stopped at 4/8, but we really didn't need to. We can keep going. 5/10, 6/12, 7/14, on and on and on. The pattern is the most important part. How do we know if these two are of the same length? Well, if we can get one of them and we multiply the numerator and the denominator by the same number and it result in the other fraction, that means they are of the same length. So for example, 1/2 and 2/4. Well, if we multiply the 1/2, the numerator by 2, and the denominator by 2, now we have 2 over 4. Well, with the same 1/2, if we multiply the numerator by 3 and the denominator by 3, then we have 3 over 6, and we can keep on going. Now that's wonderful, because with this fraction, we can change it to a lot of different fractions with different denominator, but the overall value is still the same, as long as we remember that multiplying the top and bottom by the same number. So for example, let's look at this. 2 over 3 minus 1 over 9. Well, we don't really know what that means, because once again, they're just two different length, two different value we're worried about. But if we were to change it, for example, now 2 over 3, if I multiply the top by 3 and the bottom by 3, now it becomes 6 over 9. Well, guess what? The denominator is now the same. We know that we're working with this one unit broken down into 9 equal segments, and we're worried about whatever we care about. In this case, 6, and we want to subtract 1, so it's going to be 6 minus 1. So the end result of this is actually 5 over 9. So the original problem, 2 over 3, even though have different denominator, as long as we change it to the same denominator, we know the end result is just 5 over 9. So another example, let's look at this. 1 over 5 plus 2 over 3. Well, who says we have to actually change only one fraction? We can actually change both. We want them to share the common denominator. So in this case, well, let's just look at 1 over 5. 1 over 5, I'm going to multiply the top and bottom by 3. 1 times 3 is 3. The bottom 5 times 3 is 15. Great. So we have 3 over 15, which is the same as 1 over 5. Now the other one, we have 2 over 3. I'm going to multiply the top and bottom by 5. So 2 times 5 is 10. 3 times 5 is 15. So now 2 over 3 is just 10 over 15. Well, guess what? They have the same common denominator now. We have 3 over 15 plus 10 over 15, which as a result is going to be 13 over 15. Now remember, this actually works with comparing fractions as well. So let's look at this example. Here we have 5 over 11 and 22 over 44. Well, if I want 11 to be 44, I just multiply the top by 4 and the bottom by 4. 5 times 4 is just 20. The bottom 11 by 4 is just 44. Great, now they have the same denominator. So 20 over 44 and 22 over 44, well, which one's bigger? Clearly, 22 over 44 is bigger. So even though it was very scary in the beginning, actually it wasn't so bad. It was pretty simple, pretty straightforward, not too bad, not too complicated. Remember, just multiplying top and bottom by the same number. You try.
1.
Just a keynote, I will have the answers in the description for those of you guys who are curious and want to check your answers.
3.
Thank you for sticking with me until the end of this video. Let's summarize what we went over. Fraction is a wonderful thing, but the only problem is that we really can't do much, especially when we're working with different fractions with different denominators. But luckily for us, in order to work with fractions, we need the same denominator, and all we have to do to change the denominator of one so that they're sharing a common denominator is to multiply the numerator by the same number as you're going to multiply the denominator. And just like that, with the denominator changed to have common denominators, we can do a lot of things like adding fractions, subtracting fractions, and comparing fractions. On the side note, for a trick to easily change the numbers of denominators to guarantee that they're always going to be the same, refer to my least common multiple videos. Guess what? Least common multiple can be used for that. Lastly, please like, comment, and subscribe just to show our thankfulness about the confusion that we had regarding fraction. The scariness of it can just be reduced down to working with the denominator. And when we get the common denominator, a lot of things just become so much easier. So for example, if we have something like 24 over 32 and 36 over 45, we know the bigger